Hi friends, I am Sunil working as BSNL JE. Welcome to BSNL JE 2016 exam preparation. In this video, I am going to discuss electrical specialization in this AC generators. We know that what is a generator which generates electrical energy. Which generates electrical energy? AC generator. That means AC generator generates AC and AC generates AC. That is alternating quantity. AC generators are also called as synchronous generators. AC generators are also called as synchronous generators or alternators. That means they are generating alternating quantity. That's why they are called as alternators. Okay, the working principle of AC generator is same as that of DC generators. That is nothing but electromagnetic induction. Faraday's laws of electromagnetic induction. Okay. Here the difference between AC generators and DC generators is mainly field winding is provided on the rotor. Which is rotating, and armature winding is kept on stator. Actually, in case of DC generators, conductors are, that means armature is rotating. Here in case of DC machine, that means DC generators, armature is rotating and field is stationary. But in case of synchronous machines, armature is stationary and field is rotating. Field means field poles are rotating, armature is stationary. That means armature is a stator, field is rotor. Rotor means which rotates. That means field is rotor, armature is used as a stator. Okay, that is the difference. Why? Because in case of synchronous machines, armature is stationary and field is rotation. There are several advantages in armature is stationary and field is rotating, because if armature is rotating, to collect the current with rotation is very difficult. So that's why the armature is stationary and field is rotating. One is used in synchronous machines. And coming to the frequency and speed of synchronous machines. Very important. Okay, very important. The speed of this synchronous machine is they rotate with constant speed. That is, the speed is synchronous speed. Ns equal to 120 f by p. Here ns is synchronous speed, f is frequency, and p is number of poles. From this equation we can find frequency. F equal to ns into p by 120. For example, for 50 Hz, number of poles are 2. Then synchronous speed ns equal to 120 into frequency, f equal to 50 by poles 2, that equal to 3000 rpm. For in case of 50 Hz, number of poles are 4. That means synchronous speed is 1500 rpm. That means as poles increases, speed will be reduces. As number of poles increases, speed is reduces. Okay, next, coming to the EMF equation of this AC generators. EMF for phase equal to 4.44 pi ft kp kd volts. Here what is kp kd means? Kp is a pitch factor. It is a pitch factor. Kd means distribution factor. Okay, for full pitch, for full pitch kp equal to 1, and for concentric winding kd equal to 1. For concentric winding kd equal to 1, and for full pitch and concentric winding kp equal to kd equal to 1. By applying kp equal to kd equal to 1 in this EMF equation, E phase equal to 4.44 pi ft for full pitch and concentric winding. Other than electrical pupils, other than electrical students, these words are very difficult to understand, but don't worry, just remember for full pitch kp equal to 1, for concentric winding kd equal to 1. Okay, and I will explain what is pitch factor, what is distribution factor in what is distribution factor, okay, later. Next one, types of alternators. Types of alternators. There are mainly two types of alternators based on rotors used. Based on rotors used. First one is salient pole type alternators, non-salient pole type alternators. Non-salient and salient pole type alternators. First one, salient pole type alternators. In the salient pole alternators, the poles are likewise. These are north and south poles, north and south poles. The air gap, here the air gap is not uniform. Here the air gap is not uniform. But in case of cylindrical, the air gap is uniform. Air gap is uniform. These rotors, that means these type of salient pole type rotors, driven only for low speed, driven only for low speed turbines, driven only for low speed alternators. That means these are called as low speed alternators. These are called as low speed alternators. Why these are only used for low speed means these type of rotors can't withstand at higher speeds due to this lack of mechanical support. These type of rotors can't rotate at higher speeds. But in case of cylindrical rotors, they can rotate with the higher speeds. That means these non-salient or cylindrical rotor type alternators are called as high speed alternators. The salient pole type rotors alternators are very low speed. That means the speed range is 50 rpm to 1000 rpm. Here the speed range is 1500 to 3000 rpm. To get the 50 rpm, the number of poles used are 120 poles, because we know that ns equal to 120f by p. 120f by p. To get the 50 rpm, for f equal to 50 Hz, we require 120 poles. For 1000 rpm, 6 poles. That means for 15 rpm, we require only 4 poles. For 3000 rpm, we require 2 poles. Okay. That means here, in case of salient pole type, the number of poles are very high. The number of poles are very high than the cylindrical type. So that means number of poles are high means it has the number of poles are high means it has large diameter and less axial length and smaller axial length. That means the diameter is approximately equal to 5 into axial length. But here the number of poles are very less, so it has less diameter and large axial length and these alternators are suitable for hydro and diesel type turbines, power generating stations. These alternators suitable for hydro and diesel type power generating stations. These are used for thermal power generating stations. Okay. Next, coming to the what is pitch factor, what is distribution factor. pitch factor Kp equal to cos alpha by 2. Cos alpha by 2. Cos alpha by 2. That means Kp equal to, it is the ratio of EMF with a short pitched coil by EMF with a full pitched coil. EMF with a short pitched coil by EMF with a full pitched coil. Alpha is a cording angle. Here the number of coils, all the coils are connected. Then it is called full pitch coil. If by lifting two coils or some coils they are connected, that means it is called a short pitch coil. So Kp is EMF with a short pitched coil by EMF with a full pitched coil, and this alpha is called as a cording angle and cording angle. And distribution factor, what is a distribution factor? The distribution factor Kd equal to EMF with a distributed winding. Here it is a distributed winding, and that means winding coils are distributed. This is a distributed winding, and EMF with the distributed winding by EMF with concentric winding. Concentric winding is it concentrate on only one place. It is concentrate only one place. This is a concentric winding. Okay, concentric winding. And Kd equal to sin m beta by 2 by m sin beta by 2. Kd equal to sin m beta by 2 by m sin beta by 2. Here beta is a slot angle, that equals beta equal to 180 degrees by number of slots per pole. Number of slots per pole, and m is number of slots per pole per phase. M equal to number of slots per pole per phase. For example, for 3 phase, number of poles are 4 and the slots are given 12. Then m equal to number of slots 12 per pole, slots per pole per phase. Number, that is m equal to 1. Okay. And coming to winding factor Kw equal to Kp into Kd, pitch factor into distribution factor. Very important. Winding factor Kw equal to Kp into Kd. And next, coming to the voltage regulation. That means voltage regulation means the difference of voltage at no load to full load, with respect to the full load is called as voltage regulation. It is a no load voltage and it is a full load voltage, and the difference of between no load to full load with respect to the terminal voltage, that is with respect to the full load voltage, is called as regulation. This regulation is positive whenever E is greater than V. E is greater than V means it is a positive. It is positive for resistive and inductive loads. Regulation is positive, and regulation is negative for capacitive loads. For in case of capacitive load, the E is less than V. And determination of voltage regulation. There are mainly 3 methods. Regulation can be determined the following methods. There are mainly 3 methods. First one, synchronous impedance method. Second one, MMF method. Third one, ZPF method. No need of detailed explanation about these methods. Just remember the points. First, synchronous impedance method. The regulation obtained by this method, by this synchronous impedance method, is always greater than the actual value. That means the regulation with the synchronous impedance method is greater than regulation. That means it is actual regulation, actual value. The regulation which is obtained by this synchronous impedance method is always greater than the regulation which is actual value. That means it is called as pessimistic method. This method is called as pessimistic method. Why? Because the regulation obtained by this method is always greater than the actual value. Very important bit. the following methods, which method is a pessimistic method? It is nothing but synchronous impedance method. And MMF method. In case of MMF method, the regulation obtained by MMF method is always less than the actual value. That means, so it is called optimistic method. Very, very important. This pessimistic method is synchronous impedance method, optimistic method is MMF method, and ZPF method is most accurate. ZPF method is most accurate method than the MMF method and synchronous method. Okay. Once again, pessimistic method is synchronous impedance method, optimistic method is MMF method, and accurate method is ZPF method. Or post-share method. Because it is based on post-share triangle. And next one, damper windings. The damper windings are provided in alternators to reduce the hunting. What is meant by hunting? Hunting means oscillations. So damper winding is provided in alternators to reduce the hunting. In case of synchronous motors, these damper windings are also used for starting. These synchronous motors. In case of synchronous motors, these damper windings are used for starting purpose also. Synchronous motors. These synchronous motors are nothing but constant speed motors. That means these motors rotates with constant speed. Rotates only at constant speed. That speed is synchronous speed. Synchronous motors rotates only at synchronous speed. Okay. Only at synchronous speed. A synchronous motor operates at an absolutely average constant speed regardless of load. That means the synchronous motor speed does not vary with the load. And the speed does not vary with the load means there is no speed regulation. Constant speed means there is no regulation. So the speed regulation of this motor is 0. Very, very important bit. The speed regulation of synchronous motor is 0, and the synchronous motor rotates only at synchronous speed, and it is not inherently self-starting. The synchronous motors not self-started. By using any method, by using some external, we can start the synchronous motors. And methods of starting of synchronous motors. There are mainly two methods. By using a starting motor or pony motor. Pony motor is a small induction motor. Small induction motor is called as a pony motor. By using a starting motor, we can start the synchronous motor. That is, by using starting motor, we can rotate the synchronous motor with, nearer to the synchronous speed. Then the motor will be rotates with synchronous speed. Okay. And by using damper windings, we can rotate the synchronous motor. And main important topics in synchronous motor are V curves and inverted V curves. The plot between armature current vs field current is shape of V is in the shape of V. Then so that's why these curves are called V curves. That means the plot between armature current and field current, when we draw the plot between armature and field current, the shape of this curve is like this. That means at low value of IF, the IA is very high, and then it will decreases to some point, and that point it will be increases. it will be increases. The shape of this I and IF plot is V type, so that's why these curves are called V curves. And inverted V curves, inverted V curves is the plot between power factor and field current, power factor and field current. That means this is like this inverted V, inverted V. That means at low IF the power factor is also low, and it will be increases to certain point, and then it will be decreases, it will be decreases. Okay, once again, invert V curves are plotted between IA and IF, very very important. Inverted V curves are plotted between armature current and field current. Inverted V curves are plotted between power factor and field current. Okay, okay friends, thank you, all the best. In the next class I will explain transformers. Okay, thank you.